Assalamu alaikum wa rahmatullahi wa barakatuh. So let's continue for our today's update. Okay. So in the last video only, we I showed you about I showed you the array code. Okay. Yeah. So this the array code that I did for my DSA lab for the university. Okay. So I showed you the all the array code and all the array functions, merging the arrays. Okay, and deleting the duplicates from the arrays, shifting the etc. Okay, so now let's head to the linked list. And because the video was going too long, okay, so that's why I'm breaking uh, each of these like the linked list tags and queues in like different videos so that the video don't go like crazy long. Okay, and also I can have the revision, you can say. What is that called? The Finland's theory or something? Finland's theory or something, like I can't remember. But just let me check it. Yeah, that's the Feynman technique. Okay, sorry for the mispronunciation. That's Feynman technique. Okay, like when you explain something what you have read, you get more, what to say, more firm grip on that topic, or you can say, yeah, you become better in it. Okay, you understand it when when you're able to explain that thing, you are little like you understand it. Okay, so that's the thing. Okay, now without wasting any time and all the things like update, yeah, I told you about all the updates for this like till now in my past video. Okay, so let's just dive into the link list. So yeah, I think you all can see. Yeah. So this is link list. Okay, so this is the link list suite. You can see all I like the whole code in which all the functions of the link list and all the manipulations, etc. All the things are in a single program. Okay, so actually I have divided my lab in like in four parts. The first is the array, then the link list, and the stacks and the queues. Okay, so that's the thing. Okay, so let's start. So first, yeah, including the library, input and output library, input and output stream, include stream, then using the namespace standard. Okay, scope resolution. Then we are like starting with a singly linked list that is from question 11 to question 15. We had first constructing the node. Okay, so what like making a node. So a node. Wait, just let me like open a canvas, okay, so that I can explain in the. Okay, so yeah, I have opened the concepts, you can say. So there I can show you like what I understand, and yeah, like if any mistakes, okay, forgive me, and yeah, correct me in the comments and all. Okay, so yeah, this is like we are constructing a node like a building, like a brick, a building block of the linked list. Okay, so a node, what a node will have? A node will have a data, then the a pointer like a next pointer to pointing to a node. Okay, pointing to a node. Yeah, a next pointer pointing to a node. Then we are like this is like what's to say constructor. Okay, so this is like node int value. When we will put a value in the node and use it like this, like node two, then the value will be assigned to the data, and then the next pointer will be set to null pointer. Okay, so null pointer is just like pointing to null. Okay, nothing. That's the thing. Okay, so let's just visualize the things. So let me open the concepts. We just wait a bit. So yeah, so where were we? Yeah, nodes. Okay, so see, this is a node. Like let's say, so see, I'm using my laptop's what to say, the touchpad. Okay, where it is used to control the mouse pointer. Okay, so bear with the like bear with the bad drawings. Okay, so I'm just using the touchpad. Okay, so and my fingers. So bear with it. So okay, let's say this is the node. Okay, let's say this is node n. Okay, so node, and what it has, see here. Okay, see as you saw, so it has two parts. So this is the data. Okay, where the data will go like int and all. and this will be pointing used to point to the next elements. Okay, this is used as a pointer. This here, this will have the data, and this will be pointing to the next node. Okay, that's the thing why we would like pointer to a node. Okay, and then it will have a data and then pointer to a next node. This is the thing going on. Okay, yeah. Now let's head back the code. Okay, so that's the okay. So this is the node like which I show you. Okay, so one node like here the node is defined how the node will be. Then the class is defined here. Singly linked list. Okay, object oriented programming. Yeah, there's the class name singly linked list, and it has a public section in where first we are like what to say we are assigning a head. Okay, and head is again a pointer to a node. Okay, as you can see here a pointer to a node, and then here it is the in a what to say a constructor. So okay, singly linked list, and when we will call this like when we will declare a class like singly linked list, then automatically head will be pointed to a null. Okay, so head will be again like pointed to a null pointer, and then let's start the functions. Okay, so first insert at the beginning. Okay, does it mean like inserting a data at the beginning? Okay, so it like it returns nothing, so void insert beginning int value. Okay, enter the value for like what to insert at the beginning, and then first we will be like we will make a new node. Okay, so node a pointer node will be sorry like my brothers is disturbing me. Okay, so yeah, like again a pointer will be what to say declared. Okay, new node which is a pointer to a node, and then a new node will be made. Okay, so see here we are calling a new node. A new node will be made with a value, and then the value will be inserted, and the null point and the node pointers will be and the node and this node new node pointer will be assigned to like null. Okay, like the pointer of this node will be to null because of this here. Okay, because of this constructor you can say. Then what will happen, then we will how to insert it. Okay, so new node next will be head. Okay, so the node which we made now, okay, the new node. Okay, so its next will be the head. Okay, so what to say like see head is now pointing at something. Okay, so new node next will be the head. New nodes next will be the head that is there will be stored in the new nodes next, and then the head will become and the head like the new node will become the head. Okay, so let me just explain you this right here in the concepts. Okay, so let's say okay, so this is like a head. Okay, head is pointing to this. Okay, head is pointing to this. Then we made a what to say we made a new node. Okay, here we are inserting a new node at the beginning. What we are doing, inserting a new node at the beginning. So what we'll first do, we'll make the new node's next pointer to point at the head where the head is pointing, and then what we will do, see now the new node. Okay, so this is the new node. So the new node is now pointing to the head. Now we'll make the head shift to the new node. Okay, so now the new head will become this, and this will be like removed. Okay, so now it like a new node is inserted. Okay, with a value here. So what we did, we just pointed the new nodes next to the head, and then the and made the head point to new node. Okay, so that's the thing. Okay, so now let's head back. So here, okay, same thing. Okay, new node next will like the head will be stored in the new node next, and then the new node will be pointed. New node will then the new node's address will be stored in the head pointer. Okay, so that's the thing. and then the at the inserting at the end. Okay, again void insert and the function name, the value passed, and then a new node will be made the same with the value new value. If there is no head, first here we are checking that if there is no head, that is head is not head is pointing to null. Okay, if there is no head, that means that there is no node in the linked list. So no linked list. So what we will do? We will do head is equals to new node and then return. Because see, the linked list isn't there. The linked list is empty. So we are just making the head point to the new node. Okay, so if the list is empty, then what, like there is no end and there is no beginning. Okay, so the end and the beginning is at the same place. Okay, so that's why we are just making the head point to the new node. That's the thing. Okay, and then return. And if there is like a node in the linked list, then what we will do, we'll make a temporary node, like a temporary pointer to a node, and that will store the head, that will store the value of the head. Okay, so we have made a copy of the head here, and then we will traverse that temporary pointer till the last. Okay, so while temporary next is not is equals to null pointer, while the next temporary next is not null, till then just like traverse. Okay, so we are just like traversing, going to the temporary and then temporary and like going to the next and then storing the next pointers, like the next address in the temp, and again going to the next. Okay, so doing that same again, and then like after reaching to the last, reaching to the null. Okay, like yeah, reaching to the last temporary like node. Okay, then what we'll do, we will make that last node. Okay, last node's next new node. Okay, so and then we will like exit. Okay, so let me just show you in the, what to say, in the concepts. Okay, so yeah, here, so let's see, here we are making an again a new node is there we have made. Okay, first okay, so let's say here we have made a node. Okay, first what we are doing, we are just traversing, going here and here, and then by using the temporary pointer. Okay, and then what we will do, we will just see that after this null is there. Okay, let's say after this null was there. Okay, after this null was there, so we'll stop here. Okay, so temporary is here, temporary is now pointing to this. So what we will do is there an eraser here? Points, 100 points, action, nudge, marker. Hey, there's no eraser. What you're telling? Find then. Okay, so wait. Let's say, okay, so here was the null. Okay, so now what we are doing? We are like making the temporary. So this is now temporary. Okay, so we are making this temporary's next pointer point to our new node now. Okay, now the temporary next pointer is pointing to the new node where the data is value. And you know, when we like made the constructor of the new node, what the new node is like, what the new node's next pointer is pointing to, that is null. Okay, so we don't need to like make it specific here that we make the new nodes for next pointer to null. Okay, no need. Okay, so just making the temporary pointers next pointer to our new node, and that's the node is inserted at the rear end. Okay, so that's the thing. Let's head back. So now what's the next? Delete node by the key. Key means like a value. Okay, so void again delete key function name, and then the value key. If not head, that is the list is empty. Okay, so we return, and then the case one, head itself holds the key. Maybe the head is only like the key we wanted to delete. So if that is the case, then we are going like checking that if head data is equals to key, then we have to, you know, keep the track of the address, because if we lost the track of the address, then the whole list will be like scattered in the memory and we will have no address to go and access it. Okay, so it will be lost. That's the thing. Okay, so first we are making a temporary pointer that will be pointing same to the head, and then what we will do, we'll make the head. So what we are doing, we are deleting. Okay, so that's like we are deleting the node so that because the function is only doing that. Yeah, so we are deleting the head. Okay, so what we have to do, we have to connect the like the previous nodes and all. Okay, so if the head is the key that we are going to delete, then what we will do, we will make the head the next node. Okay, so like see, if the first node is the head, then we are deleting the first node. Okay, so what we have to do, we have to change the head position. So head will now point to the head next, that is the second node. And what we'll do, we will delete the temp. Okay, so what is temp? Okay, so here you can see temp is the head. So after utilizing the head's address, now the head is updated to the next, and then we are deleting the head, okay, by using the temporary variable. And then we are, yeah, printing deleted key from the beginning. Okay, yeah, like the printing it. And then the case 2, case 1 is gone, then the case 2, that is first the case was the head is the key, and then the second is the search for the key in the remaining nodes. So now we have to search for the key. So first what we will do, we'll make a pointer current. Okay, so current is now pointing to head, that is the current node, that is head only. Yeah, and then the previous, and we are assigning previous to null pointer, because obviously like before the head it's null only, there is no double like what is a circular linked list. Okay, so that's the thing. And then so we are running a loop while the current is not is equals to null pointer, that is like until we reach the end, and current data is not is equals to key, that is until the current pointer is not null, and also the current pointer's data is not the key. Like we haven't found the end, and we haven't found the key till then, like traverse. Okay, so previous is equals to current, so we are like assigning the current value to previous, and then current will be updated. So current will be what? The current will be currents next. Okay, so we are just like traversing the area, like going here and here and okay, yeah, like until we are at the end, and also we haven't found the key. Till then, just traverse. Okay, and let me just think here. Why and? So if we have found the null, like the end and the key, so both should be true. Yeah, right. Okay, because here why we are using and, because see, we have to delete the node which is having the data. Okay, so it may be like there will be multiple nodes of the same data, so that's why until we have found the end and also the data both, till then this loop will run. Okay, so yeah, until then the loop will run, and at like till last until we found like maybe two or three elements of the same data, though that time like yeah, it will delete all of the things. Okay, but then if like okay, current data is key, then it will become true. And then current okay, so we haven't reached the end, but we have found the current key. So true false, what will become false? So no, okay, true false, so it will become false and it will come out of the loop. Oh yeah, yeah, so both have to be true, then we'll enter the loop. Okay, so it shouldn't be the last, it shouldn't be the last, and it shouldn't be the key, then it will enter the loop. And if there is a key, that is we will enter the outer loop. Okay, okay, so that's the thing. Okay, so yeah, if not current means like we have reached till the last, like current is null, that's why. If not current, then see out key not found in the list. Okay, and if like we have passed this also, like if the current is what to say, like we have found the data, and then we will come out of the loop, and here the current is like the current is like the current pointer is pointing to a certain address, so it is true. So again we will come out of here, and then the deletion will start. Okay, so what we will do, we will make the previous, okay, so remember the previous pointer is pointing to the previous node, so what we'll do, we will make the previous next. Okay, so previous nodes next will be pointing to the current next, and then we will delete the current. So then like the previous node will point to the currents next, and the current see the previous node will point to the currents the currents node next. Okay, so the chain is there. Okay, the chain hasn't been broken. Okay, and then we will delete the current. Oh yeah, the current is deleted and the node is deleted successfully. Okay, so yeah, then we are printing the cout delete key successfully and okay, so yeah, printing. And yeah, the 14th question, reverse iteration, the three pointed arms. Okay, yeah, I've heard that this is a famous interview question also, the reverse iterative. So let's see what is in here. Like, see, I was confused about this also. So I will inshallah show you here with what to say by drawing, so that I also understand and I can explain also. Yeah. So again, reverse iterative. So what is this? Reverse iterative. So we are reversing the linked list using loop. Okay, iteration, yeah, not recursion. Okay, so the next is the recursion. What we are doing first, we are making a same previous pointer, current pointer, and the next pointer. Okay, so previous pointer is pointing to null pointer because yeah, previous is null, and then the current pointer is pointing to the head. Next is also pointing to null. So now the loop, while the current pointer is not is equals to null, that is until we reach the last. Till then, next is equals to current pointer next. So the what next will be the currents next. Okay, so we have got the next. Next pointer will be the currents nodes next. Okay, and then current next. Next will be storing the currents next, and then the value in the uh, previous pointer will be stored in the currents next. Huh? Okay, so again, little bit confusion, not a little bit, but a whole confusion. Current next will store the previous. Okay, and then the current will become the previous. Current value will be stored in the previous, and then the next will be in the current. So let's visualize it. Okay, so yeah, let's make the node here. Concepts, where are you? Where are you? Where are you? Here I am. Here I am. What do you do? So let's start here using a subtle color. Where's the color? Color. Which color do you want to choose? So first, let's head back to the code. Okay, so I'm just seeing the code. Okay, till then, just file it. So while current is not equals to non-pointer, next is equals to currents next. Okay, so let's imagine three pointer. Okay, no, let's start with the two pointer only. There is one, sorry, here is node one with value one. Okay, it is pointing to a node that is two is pointing to null. Okay, and the head pointer is also here. The head pointer, what we are doing? We are previous pointer is set to null, current and the head is set to current pointer. Okay, so say where is the red color? Yeah. So this current pointer is set to point to where head is pointing. Current is also pointing here. So while current is not null, next will be currents next. There is a next pointer. The next pointer will be currents next. The next pointer will be currents next. Okay, so next pointer is pointing to here, like where the currents next pointer is pointing. The next will be storing currents next. Then the current next, and then the previous will be stored in the current next. Yes, will be stored in the currents next. Okay, let me see. Previous, the value of previous will be stored in the currents next. So the value of the previous will be, so previous is now pointing to null. Okay, so previous was pointing to null. Let's say here previous was pointing to, hey, come on, write it fast. Previous was pointing to null. So what we are doing? We are making the current's next pointer point to previous. Hmm, how it became like this? We are making the current next pointer point to previous, that is null. Okay, so we have now what next, and then the current will be previous. Current is equals to previous. Value the current previous. The current move previous forward. So previous current value will be stored in the previous. Now the previous will be stored. So now the this becomes previous current value, like the previous current value in the current previous is stored. Now in the current previous is stored. Sorry, in the previous current is stored. That is where the current was pointing. Previous is now pointing to that. Now current is equals to next. Now current is equals to next. So current now becomes the next. This is now the current. My God, what happened here? So that's the headache. What we have just did is, like, we have made here, okay. Actually, it is reversing the list. So the node becomes like this. One here, okay, and remember this is this the one node is pointing to null, okay, and this is the previous is pointing to this, and one next is pointing to null. Current is pointing to 2. So this is the, you can say, the first step this happened, and then the next iteration it will go, is current null? No, current is not null. Then next will be current next. So again, my mouse has also become like slower, what to say, too many processes in the background or what. So the current, so we are reversing. Is current null? Okay, not null. Then the next is equals to currents next. So the next will become the currents next. So now next becomes here. Next comes here. Okay. So now next has become null. Now what happened? Currents next. In the currents next, previous will be stored. In the currents next, previous will be stored. So what is previous? Previous is 1. So previous will be stored in the currents next. Okay. So like let's drag it till on where previous is pointing, currents next will be pointing to that. Okay. It is now pointing to this. Current next is equals to previous. And then the current will be stored in the previous. Then the current will be stored in the previous. So where the current is pointing, now the previous is going to point to that. Okay, so previous has gone from here. The previous gone from here and it's now pointing. Previous has become this, where the current is pointing now. Okay, so previous is this now. Then the current is equals to current next. Now the current becomes this, current next. So this becomes current. Okay. So now 2 has gone here. Okay. So what happens now? The next step, this here, remember, like 2 becomes here to the second node. Okay, the pointer here. And then the 2 is pointing to 1. 2 is now pointing to 1. Now remember, again we will go into the loop. Okay, so again we are going there. Is current null? Yeah, current is null. So we will come out of the loop. The linked list has been, what to say, uh in like inverted. Okay, so yeah, like the linked list has been reversed. So this is the process. Okay, so yeah, kind of like it's confusing also. Okay, so but yeah, let's cope up with it. So like just I'm pausing for like 2 minutes, okay, so that I can like understand and also come back and like in a simple word I can explain in 2 or 3 words, okay, so that like yeah, just let give a 2 minute. I have came with a simple, what to say, a simple explanation, or like I have understood, like you can say 90% of it. Okay, and also I'm like writing in the side that what are the topics that I'm like feeling it hard. Okay, so now see, if you're like a computer student you will understand. Okay, so like if I'm going to explain you in much detail, okay, then again I will be like confused. Okay, so let's listen with focus and imagination. Okay, imagine that. Okay, so first what you are doing, there are three pointers: the previous one, the current, and the next. Okay, so what we are doing, we are iterating while the current pointer is not null, means we are iterating till the last. So what we are doing first, we are assigning next pointer. Okay, so how will the next pointer be assigned? It is assigned by pointing, making the next pointer point to the current's nodes next. Okay, so current's next is the next. Okay, so here see, next, I hope, oh sorry, I'm showing you that. Okay, so yeah, that's the code. Okay, so we are, what we are doing, we are making the, okay, see here in this line. So what is next? Next is currents next. Okay, so yeah, in the next, currents next is store. Okay, so again, and what is previous? Previous. So previous is the back. Okay, so current next is currents next, and then the current next. So what we have to do? We have to, what to say? We have to link. Okay, we have to like invert the list. Okay, so for that we have to link the forward to the backward. Remember? Okay, like imagine just like linking uh the engine of the train to the back, like the back block of the train. Okay, so for to do that, what we have to do, we have to make the current's next pointer to the previous. Okay, so yeah, like the current's next pointer will be now pointing to the current's next pointer will be pointing to the previous one. So we have made the backward pointing. Okay, so we have made the backward pointing. Okay, so in this line, and then what we will do, we will make the previous move forward. Previous, like in the previous the current will be stored. Okay, so like we are moving forward, so previous, current, and then the next. So what we have done, we have made the previous point to the current, and then the current will point to the next. So current here, so see, previous is now pointing to where the current was pointing, and then the current will point to where the next is pointing. So we have moved forward. Okay, so that's the simplest explanation for now I can think. And like I have also understood, okay, like the linking, that the forward linking, like linking from forward to the backwards. Yeah, then let me draw in my notes what the diagram. Here is the train, one, two, three. So engine. So what we are doing? Here's the current. Here is the next, the previous. So we will make the next point to currents next, and then link back here. And yeah, like the list is inverted. One by one, the list will be inverted until the null pointer. Okay, so that's the thing. Like 90-80% I've understood. Okay, and then at the last, yeah, now the last thing that we have forgot, resetting the head to the new front. So now the previous pointer will become the head. Why and how? So let me show here in the concepts only. See which the last, where was the previous pointer pointing to? Here, remember, see the previous. See here, it is the previous pointer. It is pointing to 2. Okay. So remember, previous is now pointing to 2. So now the head is made to point to where the previous is pointing. So head is equals to 2. See the list has been reverted. Okay. So that's the thing. Now let's head back. So that's the previous is made to for like the previous value is made to be stored in the head, and then the previous becomes the new head, and then this it is printed out. The singly list is reversed. Oh my god. Ah. Now reverse using the recursive. Okay, so this is the recursive helper function. Is not the function that recurs, like it is the recursive helper function, like the engine, you can say engine of the recursive uh, function, the main function. Okay, so again, it what it what to say it yeah, it returns a node. Sorry, like I forgot the word. Like I'm explaining and understanding in the meantime. Okay, so that's like a hard thing for me. Like the first time I'm explaining and like learning, explaining also. Like yeah, I have learned, but yeah, like trying and explaining and learning at the same time and also recording at the same time. Okay, so that's why little bit what to say here with it. Okay, so yeah, the recursive helper function name, or it takes a node pointer. So it takes a node pointer. So it takes a node pointer. But why? Okay, takes a head, I think. Yeah, it will take a head. Okay, yeah, the head. Okay, so it will take a node pointer, and then until the node is null pointer or the node's next is null, return the node. So it is a base condition. Like until, like it will traverse until the last, like if the array is empty, then the node null pointer, and until the last null pointer. Okay, then from there it will again call itself node rest is equal to reverse recursive helper. It will call itself. Till then it will call itself with the argument of its next. So one by one it will like go on calling, and then what it will do, it will make the nodes next to node. Like it will make the node. So what is node? The current what is it, the stack, the current stack's node will be stored in the nodes next to next. And the nodes next is equals to null pointer. So the nodes next will be made to point to null, and then the return the rest. So let's visualize this also with what to say with, yeah, by saying. So just let me draw it. Okay, so that not the video doesn't go crazy long. Okay, so I'm just pausing. And so yeah, I've drawn, and let me show you here. Okay, so yeah, see again, the node 1, node 2, and then the null pointer. Okay, so yeah, it is pointing to 1 is pointing to 2 is pointing to null. So now let's see what the recursive function is telling step by step. Reverse recursive helper, it will do, it will take the head node. Okay, so yeah, head node. Let's okay, let's give it a head here. Like let's say the head is of course here. Then if the node is null or the node's next pointer is null, return node. Is head null? No, head is not null. Is head's next null? Like the node's next null? Okay, no, it's not null. So it will not go into the if condition, like inside the if condition. But what it will do, it will go to the next line, and here it is again called, okay, rest. The rest is called using the reverse recursive helper function. What it is going to call is going to call itself using the nodes next. So now it is here. So this here, from here it is called this, okay, nodes next. Now we are here. So now again the if condition, if the node is null pointer, is the node null pointer? No. Is node's next null? Yeah, of course. So the condition has met and it was or in between, so it will return the node. Okay. So what it will return? It will return the node. So the which node? This will be returned. Okay. So let's like mark this. Like this is returned here again back to the to say to the back to the program, and then there the next of the next lines of the codes will be executed. What is there in this? After the here after that, to nodes next is equals to node. However, nodes and like the node with that with what like like return, okay, as in the rest. So this is the rest, and then node is which one? Let's see that we have written this rest. So node is now this, I think. Yeah, node is this one now. Cause see the function when the node was this, we returned here. Okay, so the recursion like we have uh, popped this thing from the stack. Okay, so like the first node stack, the second node stack. When we came to the second node, the next node was null. So what we have done, we have just gone to this first one. Okay, so this is like gone. So here we are in the first. So node is now, let's say, yeah, the first one. So what we are doing after that, nodes next, uh, next will be storing node value. So nodes. Let's point use it another color light color. Nodes next this. Node will be stored in the nodes next. So node will be stored in the nodes next. But I can't understand. Nodes next pointer to the next pointer. So this is the nodes next pointer to the next pointer. So this pointer will be now pointing to nodes next pointer will be storing the value of node. Okay, so node will go to the okay, the debugger. Okay, so after that line, the code was the nodes. Oh, nodes next pointer of that next pointer will be storing, like will be pointing to the node. That is, what is the node? This node. So this will be now start. This will start like this will become here like this. Imagine, okay. So here is the two again. So now two's next pointer is made to point to one. So one was the node. Okay, so okay, that's the happen. Okay, the next line, node's next pointer will be null. Okay, so node's next pointer will be now set to null. Okay, so it will be set to null. So here it becomes null. Then return the rest. Now the rest is returned. So we have called the recursive, like first we have called that function, then the second time we have called that function. So we return from the second that time, and then this will be like cancel, and there's nothing to be like there. Okay, so what will be returned? Two will be returned. The rest. So what was rest? Okay, remember the rest was two. So this was rest. That means we can use this as a head. Okay, see the list has reversed. So we can use this as a head. So that this is the rest is returned. Okay, so let's head back to the code. I think I was able to make you understand it. Okay, so see here we are returning the rest. Okay, so again just a 2 minute gaps to make you understand like in a simple words or in a simple like so that I can get the words and the vocabulary. Okay, like understanding much better in a single line. Oh yeah, I've got a quite sense like see what we are doing in the recursive function. We are doing is that we are starting like we are recursively going to the end of the linked list, okay, till the last element, and from there we are starting to link recursively link the second last element to that to the last element, okay, and then making the second last element point to null. Here see next, and then returning the rest again, okay. So by that like from the last we are going to link the second last, then the third last, then the first last, okay, like this. So yeah, that's the like the easiest thing like I can tell you for now. See, it is like a hard thing for me to now understand and learn. Okay, so that thing now without like going like more what to say without taking more time, let's head back to the next because yeah, oh my God, a lot of thing is now left. So now this is the reverse recursive function, the main function here. See, we are head. So in the head, the rest is stored as I told you earlier that the rest is returned. So it will be stored in the head. And I think, yeah, the reverse recursive and the head is passed. And then the head is stored here. See out single linked list reverse recursively. But wait a thing. From where did the head came here? Okay, okay. So this is inside a class. Okay, I forgot. So because it's inside a class, so yeah, we can use the head. Okay, so that is it. And now the display function. Okay, so yeah, it is used to display the single linked list. If not head, that is the list is empty. Otherwise, make a temporary node and a temporary pointer to a node. And then while the temporary node is not null, temporary pointer is not null. Sorry. Till then, print the data. Go inside the temporary pointer where it is pointing and go into the data section and like print the data. And then move the temporary to the next and then print null at the end and the line end line also. Now let's get back to the second topic, the doubly linked list. So here we are making what to say a D node structure. So here it like the same, the data will be there and there will be two node. Okay, so one will be the previous and one node will be the next. Okay, just imagine like see the time is going like crazy long. Okay, so that's why I'm just like telling you to imagine. Okay, I will like in the later in this like maybe I will show you how it looks like. So let's imagine like the previous pointer and the next pointer and and in between the data place. Okay, so that's the thing. And again the constructor where you will like where the value will be put and then it will the data will be initialized with the value and the previous will be initialized with the null pointer and the next will be initialized with the null value too. Null ptr. Again the class next class w link list is introduced and then the public section again ahead. So again the initializer what to say, the constructor, sorry, like it will make a head to point to null, and then again the function start insert at the front. What's the time? Okay, it's 34 now. So insert at the beginning again, yeah, same like dnode, make a new node first with the using the dnode, okay, and the value, okay. If the head again, if the head is there, then make the head previous point to the new node. Sorry, the new node's value, like the new node's address, will be stored in the head's previous. So where the head is pointing, where the head is pointing to a node, so that node's previous, okay. So head previous, okay. So that node's previous will be made point to node, and then the new node next will be made to point to the head. Okay, okay, I've got it. So and then the head will be new node. Okay, so let's just let me show you here in the concepts. Okay, so here let's see. This is the node value one. It was pointing to, let's say, some other node. Come on first with value two, and it is pointing to null. It is pointing back because it is a doubly linked list, and it is head is here. Okay, head is pointing to this, and this is pointing to, say, let's say, null. Okay, so what we have done, we have made a new node. We have made it point to the, it has also two pointers. Okay, let's put the data as 0. What we have done, we have made the new node's next pointer point to the head. Okay, let me just see it. Yeah, where it is. Yeah, so sorry, first we have made the, like, linked it, okay, like the head. So head was pointing to here. So first we have made the head pointer previous, so it was earlier pointing to null. So I made the head pointer previous made to point to the new node first. This was the first, and then the new nodes next pointing to the head. I think that's it. Okay, yeah, new nodes next pointing to the head. The connection is made. Now the list has become, like, connected. Okay, and at the last, head is updated to point to this. Okay, yeah, and yeah, its previous is pointing to null only in the constructor only, as you like, in the constructor only, as I have shown you. Okay, so that this was easy. Okay, sorry. Okay, now inserting at the end. Why insert at the end? What to do? We have made a new node. Again, if not head, make the head as the new node. Okay, so if there is no node only, then the head and the tail will be all like the new node only. And then otherwise, make a temporary pointer head and traverse it to till the end, while temp next is not null, traverse it. And when it is null, then make the temporary next pointer point to new node, and the new node previous pointer point to temp because it was previous. Okay, so just let me show you quickly. Let's say this is the node I want to put in the last. Let's put the pre-data, and this is the pointer. So what we'll do, we have traversed that temporary is just pointing to this temporary pointer pointing here. So now we have made what, temporary pointers next point to the new node. It is now pointing to new node, and then the new node's previous pointer point to the temporary where the temporary is pointing. And as you know, the next pointer is already constructed as point to null, so that's the thing. So now this is added and inserted at the end and the beginning also. So now let's head back. So here, new node previous. Okay, so the 16th question. Okay, what is the 16th question? Deleting by the value. So yeah, delete value, enter the key. If not, head return because the list is empty. Otherwise, current node, yeah, make a like a pointer where the head and make it point to where the head is pointing, while current and current data is not is equals to key. Again, the same case until the current is there, like until the end, and the current data is not key. Till then, go and traverse throughout the linked list, and if there is no current, see this loop we are traversing throughout the whole list until the end. The first condition is met, like if you have reached the end, then the loop will end. Otherwise, if the current data is the key, then the loop will end. So we have let's say we have reached the end, and if not current, that is we have reached the end, then print that the value not found. Otherwise, if we have not reached the end and the loop has ended, that means there is like the key, we have found the key. So what we have to do, we have to delete the key. What we'll do, if the current's previous, so we have to link the linked list. Okay, so the if the current previous is there, that means we are at the starting. Because if the current previous is there, that means we are not at the starting, sorry, we are in the middle. What to do, we have to make the current previous next point to the currents next, the jumping like from here to here, and then else. Otherwise, head is equals to current next key was at the head. Otherwise, see, if the current previous is there, that means we are at the middle. And if it is not, that means the head is the key. So make the head is the key. So what you have to do? You have to make the head point to the next, current next, so that the what is the link doesn't break. Okay, so that's the thing. And if current is equals to next, and if the current is equal, if the current next is there, that means the current next is there, that means we are at the middle again. Then make the currents next point to the currents previous, make the currents next previous point to current previous. Okay, and then delete the current. You have deleted. So let's again imagine it here. So see, oh, see, let's make a list here. One. So see, I have to do it fast, okay, because the video is going to be too long. One, two, and three, okay. So see here, if we want to delete this node, okay. So if you want to delete this node, we are checking that if the previous is there or not. If it is there, that means we are at the beginning. So what you have to do? You have to make the current. This is the current. We have to make the current's previous pointer point to the current next. So we are making this next pointer point to here, this node, and making the current's next previous pointer point to the current's previous. So what we have made the chain, we are deleting this. And if like there wasn't like if we are in the beginning, like if the previous is not there, current's previous is not there, that means we are at the beginning. Then we just like make the current, what to say, make the head here, and the previous we don't need, we just have to delete it like this. Okay, so yeah, just let me see it in the code. The key was the head, then head is equals to current next. We are just traversing the head. Okay, earlier the head was pointing here, now the head points to the next here, because this is deleted. Okay, so no need to do all the things if the key was in the beginning. Okay, and then it is gone. Okay, so now let's head back to the code. That was the thing I was telling you. So now here I have to say, and if we are in the last element, then in the last element, if we have like if the last element is the key, then just delete the key, and then the next is pointing to null and previous nothing. Okay, so if the key is in the last, we are just deleting the key. The current next. If the current next there, and if it is not there, then just delete it. Yeah, that is the delete function, and then the display forward function. Okay, so display forward and backward. Okay, so yeah, that is like displaying forward and backward for the linked list. Again, making a temporary node, temporary pointer. Okay, so and then using the loop to point the data. Okay, so this is easy. I'm not going in the too deep like until okay, same. And then the backward. If the head is not there, that means the what to say. If there's no head, that means the list is empty. Okay, so return. Otherwise, make a temporary pointer to the like made it point to the head, and then traverse till the last, and from there see out backward, like print the backward this string, and then traverse back and like using the previous pointer until the temporary is null, so that we are just like using the previous pointer to reverse, and we are printing that. That was the thing. And then the for the doubly linked list, the last function, the reverse function, using the same the loop, I think. Yeah, if not head, that means empty return, making a temporary pointer to null pointer current, making it to point to the head, swap next and previous for all nodes. So this is like a little bit easy from the single linked list, because there are two pointers, okay, next and previous. So what we have to do, we have to just flip the next pointer to make it point to the previous, and the previous pointer make it point to the next, and then we have just reverse the linked list. Okay, so temporary is now storing the current's previous pointer. Temporary is storing the current's previous pointer. Okay, and then the current previous. Temporary is storing the current previous pointer. Then the current previous will be swapped. Like current previous will be made to point to the current's next. So it is swapped. And then the current next is equals to temporary. Okay, so here see, this is the swapping, you can say. And then at last move the current forward. Okay, so like current will be current's previous, which is currently stored in the previous. If temporary is there, like if the temporary is pointing, it is not null, then head is equals to temporary is previous. Reset the head and then see out the doubling linked list. Okay, so let's visualize this also. You're doing something, let's do it correctly and with full josh. Okay, so again make the list. So yeah, one thing forward and backward, thing to null, pointing to null. This is the head. So let's break down the function. So first, what you are doing while the current is there. Okay, so current is there. Current, let's say current is pointing to this. Okay, while the current is there, yes, temporary is current's previous. So in the temporary, current's previous will be stored. So current previous is pointing to null. So null, so temporary is now having the null value. Okay. Now current previous is equals to current's next. Current previous is equals to current's next. So the current previous will store the current next. That is, it will become this. So this is now pointing to this. Okay, so this is made to point. Okay, just like remember, this is made to point to this. Current previous is made to point to current next, and then the current next. Current's next is made to point to temporary. I think. Yeah, wait, just let me see it. Current next is made to point to temporary. Yeah, current next is made to point to temporary, and temporary is null. Let's see, we have just like reversed it, and then And then current next is made to point to the temporary, and then the current is equals to current's previous. It was current was this, and then the current is equals to current's previous. What is current's previous? Current previous has become 2. So this is now become current. Has now become current because see we have just flipped the pointer, so this is now the 2. Now again, and the same thing, like in the loop will run temporary is equals to current's previous, temporary is equals current's previous. So temporary is again current's previous, so temporary now becomes 1. So temporary is now pointing at 1. Let's see. Current's previous is equals to current's next. Current's previous, now current's next. So current previous is now was pointing to 1, but now points to null. So this now points to null. Okay. And then previous has is storing currents next, and then the will store the currents next will store the temporary. So temporary, remember temporary is storing 1. The current next will store the temporary. So say we have made the double link here, and that's it. Now we have to just make the head. So we have done the connection, and now if the temporary is there, okay. So which is temporary? Temporary is 1. If temporary, yeah, temporary is there. Temporary is there, then the head is equals to temporary previous. So head is what? Head is temporary's previous. So temporary previous is pointing to 2. So this becomes the head. See, we have made the doubly linked list reversed. Okay, so this was it. So let's head back to the code. Think you all can see the code. Okay, you don't can't see. Why code? Let me see it. Okay, you all can see the code, I think. Okay, so like it has like from 1 hour I'm recording. Okay, so like I will be taking a gap, and then we will like move to the third circular link list. Okay, so till that time, yeah, like I'm pausing here. So yeah, let's head with the circular singly linked list. Okay, the 18th question. I think this is the last circular doubly linked list. Yeah, and then the main interface program was there. Okay, so this let's start. This is the class circular linked list. Then the public section in there. Again, head node, head pointer is what to say declared. Then it is not constructed like yeah, constructor. Head pointer is assigned to null. Then the beginning, start at the beginning the function. So circular linked list is a linked list where the end is not where the end of the like where the end node doesn't where the end node's next pointer doesn't point to the null, but it points to the first node. Okay, first node, yeah, that's the thing. So insert at the beginning new node. Okay, getting the new node. Then if not head, okay, this VS code. Okay, if not head, that is if the head is not there, that means the list was empty. So make the head as the new node, and the new node next make it point to the head. So actually, you make it like circular. Okay, so if the head is not there, that means it was empty, and so the head pointer will be pointing to the new node, and then the new node next pointer will point to itself. Okay, like see, new node next pointer will point to the head. That means it has become like a circular loop, you can say. Yeah. Otherwise, if the node was there in the list, then make like declare a temporary pointer that will store the head, and then yeah, traverse like in the loop, the while loop, like while the temporary next is not is equals to head. unless temporary is next is not is equals to head. Temporary next. Okay, so see here we are finding the tail, that is we are traversing. Okay, so unless the temporary next is not equals to head, temporary is temporary next. Okay, so yeah, we have to find the tail so that we can connect the new node. Okay, so yeah, we are finding the tail, and then when the tail is found, then the new nodes. So the tail is stored in the, like the tail is the temporary is now like after ending this loop, the temporary will be pointing to the tail. Okay, so the new nodes next, new node next is equals to what it will be, head. Yeah, because see, the head will be stored in the new nodes next. So the head will be stored in the new nodes next. That is the new node next will be pointing to the head. Okay, so that is, and then the temporary is next, like the tails next will be point to the will be pointing to the new node. Okay, so we have found the loop, and then we make the update the head. Okay, so if I want to show you, let me just show you in the concepts. Okay, so here, okay, just let me show you. Okay, so this is a linked list. Okay, you can say a circular linked list one, and then it points to two. Okay, and then put 2 points back to the first node. Okay, so if we are inserting at the beginning, we have to find this tail. So after we have found the tail, so this is the new node. Okay, let's say we are inserting here. There is a zero, and this is the new node. So we have to now the head is pointing here, and this is the tail, you can say. So we have traversed using the temporary pointer. We went here, and then what we are doing, we are making the temporary next pointer point to the this making the temporary next pointer point to this. Okay, but just let me clear up, like temporary next pointer. Okay, so first we are doing is that new nodes next pointer to head, new nodes next pointer to head. So what we are doing, we are making this new nodes next pointer. Okay, so like you are able to like understand. So we are pointing the new nodes next pointer to the head, and then what you are doing, we are making, just let me check. Yeah, temporary is next pointer to node. Okay, so this was the temporary, and then the temporary is next pointer to node. Okay, so yeah, we are the same. We are pointing this to the new node, and then what we are doing, we are updating the head. So now the head becomes this. Head is this. So now I can you can see that it is connected like this again. Yeah. Okay. So see, it starts from the zero, then goes to one, then goes to two, and then two comes back to zero. Okay, so yeah, we have found the like we have made the inserted the node in the circular linked list, and then inserting at the end. Okay, so again new node using the new node value again. We are making this. You are using this node from the single linked list. Okay, the struct, and then if the head, if not head, that means nothing was there, empty list. So we are just making the new node, and the new node next points to the head. That is, we are just making the circular, like making the head, making the new node head, and then making the new node's next pointer points to itself. Okay, that's the thing. And then otherwise, if there were nodes in the list, then again making a temporary, that is a temporary pointer, and storing the head address there, and then traversing the using that temporary, we are traversing throughout the list, and then so we are inserting at the end. Okay, so what we have to do, we went to the last element. There what we have to do, we have to make the last elements, that is the temporary, and temporary's next pointer point to the new node. Okay, so we done that, and then the new node's next pointer points to the first. So how we will get the first head? Okay, yeah, so see, we have got the head also. So this is the line. So should I show you? Okay. Okay, sorry. I forgot to switch the window. Okay, so wait, let me show you. So we were here, okay, right? So let's see, this is the node again. One pointing to two, and two, let's say two is now was pointing to one. This is a circular linked list. Now we want to add a node at the end. So what we will do, let's see, this is the new node. Okay, this is the value three. Sorry, just there with the drawings. Okay, so this is the three. So what we will do, we will make that this was temporary because this was the last node. Now what we will do, we will make the temporary next pointer point to the new node, and then the new node's next pointer point to the head where the head was pointing. So head was pointing here, remember, and we traversed through the using the head, and the temporary we traversed here. The temporary was pointing to here. Okay, remember, and then this is pointing to this, and then this becomes a circular loop, circular linked list. Okay, so that's the thing. Now let's head back to the code. Okay, so yeah, see the code. Okay, so this was the inserting that at the end thing as I told you, and then the deleting the node, the same I think. Yeah, if not head, then return. That is there is nothing in the list. Otherwise, make a current pointer make it point to the head, and the previous pointer make it point to the null. We are using current and previous pointer so that we don't lose the links. Okay, otherwise the the captured data like the link list will go into the available list where like in the heap, and it will be lost. Okay, so we can't like point to that address, so we will lose the address. That's the thing. Okay, now handling the head direction. If head data is equals to key, if the head is only the key, then what to do? Make the heads next is if heads next is equals to head. If the head is the data, means if head is the key, if the head's data is the key, then check if the head next is equals to head. If head next is equals to head, that means there is not like if the head next is equals to head. This means that if the head next is pointing to the head itself, that means it was a single node. So what we have to do, just delete the head and make the head pointer point to null. Okay, that's the thing, and then return. And if it is not the case, that means there are more nodes. So here what we will do, we'll make a tail pointer will point to the head, and then yeah, traverse and make the tail pointer point to the last element. And then what we have to do, what we are doing, we are deleting. Okay, so we are making a temporary pointer which is bring the head again, and then what we will do, head is equals to head next. Oh, wait, okay, so we are in the head, and head is the key, and there are more elements, so we are in this time. Okay, so yeah, temporary is equals to head, that is temporary is now storing the head, temporary is now storing the head address, and then the head is now updated here in this line, that is head is now updated to the next node. And then what we'll do, and then the tails next is now pointing to the head, so we have made the loop, and then we are just now easily deleting the temporary. Okay, so yeah, and then returning, and then return. Okay, so that's the easy thing, I think. We all have understood. I don't think I have to show this. Okay, and then the last thing, okay, not the last, like the searching for the key. So if the head was the key, then there is the thing, and if not, then we have to search for the key. So while current next is not is equals to head, so while the current next is not is equals to head, that is we are not at the last, and the current data is not is equals to key, means that we haven't found the data. Until then, go on traversing. Reverse is equals to current. That means we are updating the previous to current, and the current is also current next. So we are just traversing through the list. And then if we have like reached the end, or we have found the key, then what? If the current data is equals to key, that is we have found the key, then previous next previous next is equals to currents next. We are connecting the loop, and then deleting the current. Okay, else otherwise we have ended the loop, and we haven't found the key. So what we have to do, we have to print the key not found in the circular list, and then the display function. If not had, that means there is no circular list is empty, though there is no node in the circular list. Okay, otherwise there are nodes, and then temporary pointer which is pointing to the head, that means yeah, same. And circular we are printing, like doing a do loop, see our temporary data, and then go to the next, while the temporary is not is equals to null, I think. Yeah, not is equals to head, sorry. Like the end, because see in the circular list, the temporary the and the last cannot be null, it should be head, because we are just reconnecting it back, the tail back to the head. Okay, that's the thing. Okay, then yeah, So this is the main function. Again, we are uh, using the class, like the class, to make an instance of each of the class, single linked list and the double linked list and the class linked list, like an object, you can say, yeah. And then, yeah, in choice, do these things until, okay, do all these things until, wait, the condition will come down. Okay, so print all these things, then switch choice, case 1, case 2, case 3, case 4, all this case. Okay, so let's read the case and all. So first we will insert the end, insert in the end 10, then the 20, and the beginning 5, and then the current. Okay, so you all can read this. Okay, and then deleting the key. Okay, using all the function that we have made, SL reverse, singly linked list, reverse iterative display, then reverse recursive and all. Okay, so yeah, these are the things in the case 7. Case 0, exiting the playground and break, and then a default invalid choice. Okay, while the choice is not is equals to 0. Okay, so do all these things, do all these here, do all these things until the choice is not equals to 0. And when the choice is equals to 0, exit and return 0. Yeah, that's the thing. So let me just run the program and show you. This was the slash OA CPP linked list CPP, yeah. Oh, okay. So we have compiled the code. Let's see it gets compiled on. Okay, it got compiled. That slash A. So here, see, this is the grand linked list playground. So we have got the playground. Okay, so what we have to do first, insert front and end display. Okay, let's choose the first one. So see, now we have inserted choice one. Current singly list 5, 10, 20 null. Okay, and then again, let's see what happens if we turn on. Okay, so again, see, as I had shown you in the main only, where like it got add like see 10, 25. So again it got added like see 5, 5, 10, 20, and 10. 5, see 5 is here only. So again it got add up, where see first it was 5, 10, and 20. 5, 10, and 20 got added, and then the null. Okay, so again it got add up. So let's try a different thing. What to try? Delete key. Let's try the second. Enter the value to delete. Let's delete 20. What happened? See, here. Enter the value, delete. Deleted 20 successfully. 5, 5, 10, 10, 20 null. So 120 is left. Okay. Let's see what happened. I'm not going to debug it this time. Okay, I will do it afterwards. So now let's try a different thing. Let's do the seventh thing. Circular list, insert, delete, and display. The circular list 1, 2, 3. Back to the head 1. Deleting 2. Circular list 1, 3. Okay, back to the head 1. Okay, so it worked. And then let's exit the program. So yeah. So I think, yeah, I've shown you all the link list code, and explaining it, and like understanding, like learning, revising it in the meantime, and also recording was like yeah, a challenging task, but yeah, I did it somehow. And like the Feensman's theory, something like that. When you explain the things, you learn more quickly, and you grasp the topic more clearly. Okay, so yeah, I got the things, and it's good. Okay, so now let's end the video, otherwise it will be crazy long. So jazakallah khair for listening me, and in the next video we'll see the stacks code, and also in the next queues code also. So thank you all, and jazakallah khair for listening.